This is the A2 example video for finding y-intercepts. So, given two graphs here, I know my y-intercept is where my function, or my line in this case, crosses the y-axis. So also my x-coordinate would be 0 at these points. So if I'm taking a look at this line right here, I'm going to take a look at my y-axis, and my y-intercept would be wherever my line crosses the y-axis. So here, it would be at -1. Right, looking at this graph over here, where my function crosses my y-axis, so my y-axis is right here, and this line crosses at +4. Okay, pause the video if you need more time. Okay, so for this example right here, I have a slope-intercept form equation, so I know y equals mx plus b. So to find my y-intercept, I'll just set x equal to 0. So y equals -5/4. Instead of x, I'll plug in 0, plus 1. So if I simplify this, y equals -5/4 times 0 is just 0, and I'm left with plus 1. So my y-intercept would be 1. So if I had a graph of this linear equation, it would cross the y-axis at 1. Okay, so moving over to the standard form equation, I'll do the same exact thing I did for the first example. Instead of plugging in x, I'll plug in 0. Okay, 8 times 0 is 0, so I'm left with -3y equals 9. Now I need to solve for y, so to get the y by itself, I can divide both sides by -3. -3 divided by -3, they cancel out, so I'm left with y equals 9 divided by -3, which I know is -3. Next example, I have a line in point slope form. So I have y minus 3 equals -1/2. Instead of x, I'm plugging in 0, because I know whenever I'm looking for a y-intercept, my x-coordinate will be 0. So if I rewrite this, I have y minus 3 equals -1/2. 0 minus 4, I know is just -4. So I'll keep simplifying. I have y minus 3 on this side. -1/2 times -4 is +2. Okay, so to get y by itself, I will add 3 on this side. I will add 3 on this side. So these 3's cancel. I'm left with y equals 2 plus 3, which is 5. Pause the video if you need more time. Nope, we don't want to get into slope notes quite yet. Okay, so I have another slope-intercept form equation, y equals mx plus b. That won't change my process. I will still set x equal to 0 because I'm trying to find the y-intercept. So -5/2 times 0 is just 0. So I'm left with -4 on this side, and I'm left with y on this side. So my y-intercept is -4. I have a standard form equation here, so 9 times 0 plus 4y equals 20. 9 times 0 is 0, so I'm left with 4y on this side and 20 on the other side. So to get y by itself, I'll divide both sides by 4. 4's cancel on the left, so I'm left with y equals 20 divided by 4, which I know is 5. Okay, last example, point-slope form equation. So, no, I'm not going to change my y at all, but I will change my x to a 0. So if I rewrite, I get y plus 1 equals negative 2 over 3 times negative 4. So on this side, I'm left with y plus 1, that doesn't change, and I have negative 2/3 times negative 4, which gives me positive 8 over 3. So I'll solve for y. So, whoops, before I do that, I know I have to subtract 1 from both sides. Ones cancel over here. So I'm just going to go up here because I'm running out of space. Maybe you can use another piece of paper, or maybe you have enough room to fit this in. But I'll go up here. So I'm left with y on the left side equals 8 over 3 minus 1. So I have a fraction here and I'm subtracting. So I know I need a common denominator. So my common denominator here would be 3. Because I have 8 over 3 here and I have negative 1 over 1. So to get this to have a denominator of 3, this 1, or this negative 1, I have to multiply by 3 over 3. So I have y equals 8 over 3 minus 3 over 3. So I know y will equal 8 minus 3, which is 5, and 3 will be my denominator. 5 divided by 3 does not simplify, so I know my y-intercept is 5 over 3. If you got confused somewhere in this process with the subtraction of fractions here, or me trying to find the common denominator, just ask me in person, okay, and I will clarify things for you. So now that you've seen examples on how to find the y-intercept given a graph or any linear function, you are ready for y-intercept practice A, B, or C.